My name is Vereshchak.
And my name is Karan Chandwaney, and we are software engineers at Garmin.
For years since the GPS has been around, it has had high readings of inaccuracy. 95% of GPS systems have up to 10 to 15 meters of uncertainty, which can be dangerous and misleading. Garmin is a well-established company, and through new technology can bring the inaccurate readings from meters to centimeters, will give Garmin a step ahead of their competition.
Even with all the updates of the 21st century, GPS systems still manage to cause troublesome errors. For example, a 67-year-old woman was set off course by 900 miles due to GPS inaccuracies on a ride that should have been only 90 miles. This problem resulted in a loss of sales and market share for the company.
A few methods that we have to fix the problem of GPS inaccuracies are differential GPS. This method uses base stations that are in precise known locations and compares it to GPS coordinates to eliminate the error percentage. This method is based off having several base stations that are at known coordinates and are spaced relatively close together. The base station's GPS receiver calculates the difference in coordinates and compares it to the next base station. The corrected information is then used to make the readings of the GPS coordinates more precise.
Another method is extended differential system. This unifies the data of different receivers around an arbitrary point and relates the readings with time. It then produces a systematic equation of errors every 40 minutes to bring the inaccuracy down to just 1 meter. By using a network of differential GPS stations, one can compute a differential GPS message that provides corrections for the different components of the accuracy error. This allows the differential GPS navigation accuracy to be extended to a range of 1,000 miles from the master differential station.
Another method is real-time kinematic. It is a technique that uses measurements of a signal carrying navigators, where only one reference station provides correction in real time. This method measures the magnitude of sinusoidal wave from its origin, which the signal carrier emits, instead of the information content of the signal. It relies on a single reference station to provide real-time correction. This results with accuracy on a submetric level.
Here's what our timeline looks like. On the 30th of September, we plan on commencing our prototype research. On the 2nd of October, we will submit the official proposal. On the 15th of October, a budget meeting will take place to divide and allocate funds across our team. On the 20th of October, the construction of GPS base stations and receivers will commence. We plan on finishing construction on the 1st of November. We will start signal and accuracy testing on the 2nd. On the 10th, we will test our prototype with members of the public. On the 15th, we will accumulate the results and perform a final accuracy check. On the 20th, we will submit the formal analytical report.
We would still like to conduct more research into our three methods of slimming down GPS inaccuracies. We must find out exactly how much each of our methods will cost. Finding out which method is more economic would help determine the smartest route to go with. Another important aspect that must be researched is efficiency. With such a fragile environment now, we cannot afford to continue to keep damaging it. The chosen method must be able to conserve power and have little to no impact on the environment and the atmosphere.
This project will be expensive, but Garmin's current income can easily afford it. When all the research is finalized and a preferred method is chosen, Garmin GPS will be the most accurate GPS system on the market. This will make Garmin a favorite company, which will increase the company's reputation over the years, resulting in a higher profit per annum.
That being said, we would like to request permission to proceed with the budget and research to come up with a formal analytical report. If accepted, the formal analytical report will be ready by November 20th, and all due dates will be strictly adhered to.